Good evening. I studied the effects of arbuscular mycorrhizal fungi on tomatoes growing in gravel and soil. Before we continue, you should learn a little bit about me. My name is Seth. I attend Chatham High School, and following graduation, I was in Coastal Carolina University. There, I will major in exercise science. I chose this topic because growing up, my family has always had gardens. This means I have grown up around plants and have seen the struggles with growing them. I'm also aware of the nutrients plants give us, often providing us a lot of our proteins and many other macros. My health is important to me and many other people, so it is important to know how the plants are being grown. This study is needed because plants can produce inconsistent levels of fruit yield. Since farmers make a living off of selling their produce, an inconsistent fruit yield can be detrimental. However, this study can help plants produce more consistent levels of fruit. As said in the name, AMF is a type of mycorrhiza, meaning it forms symbiotic relationships with the plant. AMF increases the root's absorption area and provides carbon for the plant. In return, the fungus receives sugar. This picture shows the AMF being connected to the roots of the plant. By increasing the root's absorption area, AMF aids in the acquisition of immovable nutrients because it allows the plant's roots to reach more nutrients. AMF can also enhance plant characteristics such as plant quality, yield, and nutrient content. Finally, it can alleviate stress. There are two types of stress, abiotic and biotic. Abiotic stress is caused by non-living things, and some examples include drought, excessive rain, high temperatures, or salt. Whereas biotic is caused by living things such as insects, viruses, and weeds. Abiotic stress is easier to notice because we can physically see the problems arising within the plant. However, biotic is not so easy because we have no way of knowing if the plant is infected with the virus. Soil substrates can help with soil availability. There's been a significant decrease in the amount of arable land, and soil substrates can help with this because it allows the growing of plants in little to even no soil. Since many people are not given the green thumb, or the ability to grow plants well, they should consider soil substrates because of the ease of controlling variables. Plants grown in soil substrates also tend to have a better quality, such as better color, more sugar, and a better taste. The use of soil substrates date all the way back to the Egyptians through their hieroglyphics. However, some popular examples include Disney World Epcot's Land Pavilion, as shown in the picture, and the Hanging Gardens of Babylon. There are two different types of soil substrates, inorganic and organic. Inorganic mediums have no carbon, and some examples are sand, rock wool, vermiculture, and gravel, whereas organic mediums have carbon, and some examples are coir, sawdust, compost, and manure. Inorganic mediums hold the nutrients longer than organic, allowing the plant longer periods of time to access the nutrients. However, organic mediums offer greater nutrient levels, allowing the plant to receive more nutrients. There have been many studies testing the effectiveness of AMF and soil substrates. However, nobody has tested them being used together. This will provide knowledge about whether or not AMF and soil mediums could increase the plant's fruit yield. Therefore, with all this being said, my research question is, how does AMF affect the tomato plant's yield when grown in gravel and soil? My null hypothesis is that if half of the plants are inoculated with AMF, then there will be no difference in the fruit yield. And my alternative hypothesis is that if half of the plants are inoculated with AMF, then the AMF group will have a greater yield. My independent variable is AMF inoculation. 30 of the 60 total plants were inoculated with AMF. My dependent variable is fruit yield. I measured the fruit yield for both groups and compared them against one another. My control group was the plants that did not receive any AMF, and this group was used as the comparison. My constants were the amount of water, the location, the type of soil, the amount of sunlight, and the temperature. However, for the temperature, I was not able to control it, but each plant was grown in the same temperature. From my methods, first I gathered all the materials I would need. These included the 60 tomato plants, CXISR AMF, styrene soil, gravel from a quarry, and eco-friendly buckets to place the tomato plants in. After I obtained its materials, I mixed the soil in with the gravel in a 2-to-1 ratio and placed it in the buckets. Next, I transplanted the tomatoes from the seedling pots into the buckets. After that, I randomly selected 30 plants to inoculate with AMF and inoculated those plants. Over the 3-month period that this study was conducted, I watered my plants every other day to ensure the plants not overwatered. Also, to ensure that the plants were producing tomatoes and that no tomato went to waste, I picked ripe tomatoes every 2 days. I also did a full count of ripe and unripe tomatoes for each plant to find which group was producing more. After the 3-month period was over, I compiled my raw data and conducted statistical analysis. This graph shows the individual yield for each plant, with each day being represented by a different color. I chose this graph because it shows how each plant compares to one another. This box shows the average and spread for both groups. This shows a very little difference between the 2 groups and that most of the yields stayed in the 5 to 10 range. This means that AMF did not provide the advantage that was expected, which was an increase in fruit yield for the AMF group. This graph shows the combined yield for each group. This graph is used to show a change of time, allowing for an easier way of seeing the difference. The black box shows for the 28th and 42nd day of data collection, AMF began to provide an advantage. However, some limitation caused AMF to stop providing this advantage. For this study, I chose a 2-way ANOVA as my statistical analysis test. I chose this test because it allows me to compare multiple groups against one another while also taking account of any extra variables. For this study in particular, my 2 groups were the AMF group and the non-AMF group, and the extra variable was that the plants were growing in gravel. Once performing this test, I found that at the significance level of 0.05, the null hypothesis was not rejected with a p-value of 0.63. This p-value means that there was not a significant difference between the group that was inoculated with AMF and the group that was not, meaning that AMF did not provide enough evidence to show that it can benefit plants that are grown in soil mediums or at least in gravel. This also means that my research hypothesis was not supported, as the p-value did not show a significant difference. Even though the plant yield increased a little, there is not enough proof to show that AMF caused it. Therefore, AMF may not be as beneficial as previously thought. AMF has been shown to increase many characteristics of the plant, including its yield. However, the introduction of the soil medium may have caused the AMF to not be as beneficial as it could have been. This allowed me to learn that certain environments may cause AMF to be less beneficial than it would be in just soil. The results from this study show that AMF, while in combination with soil mediums, do not increase fruit yield. Since both groups were very similar to one another, there is not enough proof to show that AMF and soil mediums cause any form of an increase. Therefore, the results from this study differ from previous studies. For example, one study tested the effects of AMF on plants and the other the effects of gravel on tomatoes. For both groups, the fruit yield increased so that they can benefit the plant. However, while combined, they do not, meaning that this provides no benefit to farmers. I was hoping for this study to enhance farmers' fruit yields in unique environments, such as mountains where gravel would be prevalent. However, this study did not show the results to support this. During this experiment, I also ran into a few limitations. My first limitation was summer vacations. Over the summer that I was performing this experiment, my family and I went on vacations. This means that I had to trust someone else to water the plants for me, pick the ripe tomatoes, and keep track of it. Since this task takes a long time, the person could have done it half-heartedly. The next limitation was location. I did not have access to a greenhouse for this experiment, so I grew the plants on my carport as shown in the picture. This means that the plants received the morning sunlight and afternoon sunlight, but were exempted from midday sunlight. Finally, during this experiment, some of my tomato plants were infested with insects. These insects would eat the fruit, and any tomato eaten by an insect was not included in the final yield. Future research should focus on the use of AMF on plants grown in different types of mediums. Whether the medium is organic or inorganic, different mediums should have different effects on AMF. Future research should also test the effectiveness of AMF in gravel on different plants. Tomato plants are not the only plant proven to be benefited by AMF. Therefore, other plants should be grown in gravel with AMF. While performing this experiment, there are some things that I learned. First of all, I learned that results don't always meet expectations. I expected my results to show an increase in fruit yield for the AMF group, but this did not happen. However, this does not relate to just research though. Just because one outcome is expected does not mean it will always happen. I also learned the usefulness of research, whether in order to find a gap to perform a new study, or to understand the pros and cons of a new form of research, a new form of medicine. Research will always be able to help me throughout my life. I'd like to thank Ms. Long for helping me throughout the entire inquiry process, the Southside Quarry for providing me with my gravel, Paul Stryker for providing me with my buckets, and the Home Depot for providing me with my soil. Thank you. Are there any questions? Yes, Ms. McCraw?
In your methodology, you explained that you inoculated 30 plants with AMF. Could you further explain that inoculation process, please?
Ms. McCraw is asking how I inoculated my plants with AMF. So the AMF that I received came in little pellets. So I dug 3 holes for each plant and poured the pellets down the hole. So that way the AMF was near the roots and I was able to connect to the roots easier. Yes, Mr. Taylor?
So I noticed in your methodology, you used count of the fruit to measure the yield.
Yes, sir.
In any of your research, did they use any other measuring techniques of the fruit?
So Mr. Taylor is asking if any other studies tested any other effects of the fruit. Some of the articles that I read, they would measure like the nutrient content of the plant, the amount of sugar, dead weight, but I just chose to measure the individual yield.
And I have one more. How did you land on cherry tomatoes?
Mr. Taylor is asking how I land on cherry tomatoes. So I have a family friend that would grow tomatoes, and they all grew cherry tomatoes, but since she had enough, we decided that we would take cherry tomatoes to keep the plants all similar, and that they had enough of it at one time.